want to make decimal to accessory encoder. So what it means, decimal to accessory. So it means you want to have one encoder, which is input is decimal number, okay? So you consider from M0. So you have 0, you consider 1, you consider M2 as a other input, M3, M4, M5, M6, M7, M8, and the last decimal you could consider M9, right? So which is, we have the 0 to 9, we label the input M0 to M9, and it should be decimal to accessory. So that means the output code, what should be, what is the 0 in accessory? Remember that? If you have 0 decimal number, what is the accessory code for 0? Yeah, 3, definitely right. We actually have a table for that, but definitely need that table. Accessory is clear from the name, right? Its midterm, is its base 2 plus actually 3, right? So that means the 0 should be 3 accessory. So that means what is the 3 is 0, 0, 1, 1. So that means if I label the output E3, E2, E1, and E0, there should be 3. What should be M1? So you say M1 in accessory should be plus 3, should be 4, right? So 4 is 1, 0, 0, 0. How about 2? 2 plus 3 is 5. So you should have 5 here. What should be the next? Should be 3. 3 plus 3 is 6. You should have 0, 1, 1, 0, right? 4, 3. What is 4 is 7. What is the next is 8. What is the 6? 6 plus 3 is 9. What is the next is 7 plus 3 is 10. And so 10 is 8 plus 2. And 8 is 11. So this is 11. And 9 is 12, right? You have 1, 1, 0, 0. Okay. So this is what you want to actually design, which is called that decimal to accessory encoder. Why? Because the input is midterm 0 to 9, and the output is not the binary, which is happen in the normal encoder. Here, this is actually the accessory code. That means whenever you have M0 should be give this, whenever you have M1 is 1, other 0 should be get this, and whenever that is M2 should be this, right? So if you take a look to this table, and with the previous example that we had for designing encoder, we know how we could make that, right? For design encoder, we have the midterm here, and we have the codes here. You just add one OR gate for each of them, and the connection is whenever they are 1, right? Here is 2 and 3, and 0 and 1 as 1 and 3 for x0 in previous example. But for this is exactly the same thing. For each of these, you need an OR. That means you need 4 OR. Just check the columns. Whenever they are 1, just make the connection in that column, right? So I go just use the other colors. So that means here I need how many inputs? So similar with the previous one, I need 9, right? So I'm going to draw. Yeah, it's really tough to do this with this pen, but to try our best. Yeah, maybe. Okay, so I need 9, 10 actually input. I actually put one line for each of them. So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, 7, this is 8, this is 9. I don't know, we have enough. 1, 2, 3, 4, 5, 6, 7, 8, 9. We need one more, right? Which should be 10. So just give the name for each of them. Use the other color. So the first one you could call this M0, this is M1, this is M2, this is M3, this is M4, this is M5, this is M6, this is M7, this is M8, this is M9. Okay. So now for each of these output, you just need one OR gate. So see, I just put one OR gate here. You actually call that E3. So the other one here is E2. These are the OR gate. So this is E2. The next is E1. Next one is E1, and the last one is E0. Okay. So just check the column. So wherever you have 1, definitely you should have connection there. If I check E3, just you have 5 to 9 should be connection. So I put 1, 2, 3, 4, 5. Okay. Check the E2 where it is 1. It should be 1, 2, 3, 4. So comes here 1, 2, 3, 4. We have one more at 9. So one more at 9. Check the E1. So you have on 0. You have on 0. So then you have on 3 and 4. So this is 3. This is 4. And then you have in 7 and 8, right? You have in 7 and you have on 8. And the last one is 0 and 2. So this is 0, this is 2. So then you have on 4. So this is 4. Then you have 6. So this is 6. Then you have on 8. Just put on 8. Okay. So just check your circuit. For example, whenever M9 is 1 and the all other is 0. So based off this table, it should give me 1, 1, 0, 0. So this is 9 is 1, the all is 0. So whenever this is 9, it's connected to here. So this should be 1. It should be 1. And the others actually is the 0, right? So that means this is 0, 0, which is right. So that's the reason you take a look to the column. Wherever they are 1, just put the connection. So this circuit is somehow is a encoder, but that's the encoder, which is convert decimal to excess3. If that's a normal encoder, so you should actually have, because you have 4 here, how many midterms do you need? 16, right? 16, and you write the binary of that for each of them. So that means if this is normal encoder, whenever it is 0, it should be just 4, 0, not 0, 1, 1. But here we want to actually have decimal to excess3. So that's the reason we actually made this table, and we have this one, which is the circuit, which is how somehow is encoder decimal to excess3 encoder.